Welcome back, and I'm glad to be here to introduce you the last workshop for track 2. My name is Uriel Sinan. I'm a Shiny developer at Epsilon, and today we'll be seeing and enjoying this workshop entitled "Why is it triggering twice? Understanding Shiny Reactivity." The workshop will be conducted by Douglas Mesquita. Douglas is now Shiny developer at Epsilon and has a longer career as an R developer, as he was using R for his research in statistics. Please have your laptops ready, grab some coffee, and let's give a warm applause to Douglas for this amazing and exciting workshop.
Thank you, Oriol, for the introduction, and hello, everyone. Today we will be talking about reactivity in Shiny, and to be honest, selecting the title was the easiest part of this presentation because, as Oriol said, I'm working with Shiny for such a long time, and I can't remember how many times I asked myself this very same question: why is it triggering twice? And during this time, I collected some possible problems, and then I will try to share with you things that may be happening in your application and maybe to be helpful for you to improve your application in the future so it will not trigger twice. So let's start. In the next 2 hours, we'll be talking about it, but we will have a short break in the middle so you can grab some more coffee, water, and rest a bit. Please let me know also if the audio is okay, and at some point we'll see some code here, so if the font size is good and everything's working fine. So this is the overview of the presentation today. It's divided in 6 parts. First of all, we will be talking about the reactivity itself, so we'll try to understand how it works in Shiny. Then we will move on to the core reactive elements that we have in Shiny, some unexpected triggers that may happen, how to control better the execution, how to optimize the reactivity, and in the end, I will summarize everything that we discussed today. Before starting, just a short introduction. So as Oriol said, before joining Epsilon, I was working with research. I did master's and PhD in statistics, and I'm working here in Epsilon. Wait, sorry, you are not seeing the screen. I'll just come back a few slides. So this is the cover page, sorry. This is the overview. So the first six topics we will be talking about, and I was talking about me a little bit. So as I said, I did master's and PhD in statistics, and I've been working as a Shiny developer for Epsilon for the last 3 years. So I'm working daily with Shiny. As a statistician and data scientist, I'm in the field for 10 years or a bit more, and also I'm open source contributor. So it was good that I didn't share the screen in the very first slides because they are not that important. But before we start, we need to know a few things. So first of all the content I'll be sharing here, it's in my GitHub. Oriol will be sharing with you in the chat. If you did a pull yesterday or some other time in this repo, please pull it again, because as you see, I updated it not a long ago, so there are some new things there. Also, after doing that, you can run this piece of code just to restore the package we are using. It is just 3 Shiny cookies and Shiny.js, if I'm not mistaken. And very important, run the examples in the browser, because we are going to use cookies in some examples, and it will just work in such case. All right. Also, before we start, let's see where is the reactivity happening, right? So we are developing Shiny applications. We have our UI, we share it with our clients. There are several buttons on it. We can play with the inputs and outputs. And also we are aware that we have the server side. The server side is our brain. It is where the calculations are happening. So based on the inputs of the users, we are going to transform it somehow and bring it back to the UI with some outputs to our user. It means that the reactivity is happening right in the middle. So when someone changes something in the screen, our server will receive this information and a process will start. So we will start doing a lot of calculations based on the inputs that the users are providing and feed it back in the UI. And this is the reactivity. So we need something that's changing. With this thing that's changing, we can update our output here, our outputs here. And all right, so let's understand deeply what's the reactivity in Shiny here. This example, actually, I stole from a friend. He also works at Epsilon, Veda, and I found it very interesting to display it like this. It seems a bit weird now, but it will be clear in the next few slides. These are all the functions we have in Shiny, specifically in Shiny 109. And like in these functions, we have things that are just updating the UI. We have wrappers for HTML content, but also we have functions that are related to reactivity. And these are the ones that are highlighted in this slide here. Everything is in alphabetical order. So I just collected the functions and I put it here in alphabetical order. But of course, we can reorganize it in a much better way. For example, like this. And in which, in the left side, we have everything that's related to the inputs that the users can see in the screen. In the right side, we have things that are related to what the users are also seeing in the screen, but more related to outputs or endpoints, for example, the observe, but we'll discuss it later. And in the middle, we have some conductors. So these are elements that are taking inputs, processing it, and then in the end, it's giving to some other functions information in which will be displayed in the user screen. If we have a close look at this, we can still simplify this amount of functions because there are a lot of them. I will not read the name of everything, but we can see that some functions here, they have this pattern like input in the end. Some other functions, they have a pattern at the beginning, for example, action button, action link. The same for the outputs, the render functions, and so on and so forth. If we simplify, we can see the functions that we are going to talk about today in a much easier way. So these are the functions that are related to the reactivity. If I didn't forget any from the previous slides. And well, as I said, these are the inputs or source, as we will call in the rest of the presentation. These are functions that are either conductors or helpers. And here we have outputs or endpoints. We are not going to talk about all of them, but most of it. So the ones in blue are the ones that we are going to talk a little bit, at least during the presentation. Also, we use these shapes here to represent the behavior of each one of the functions that we are going to talk about. Okay, and we will give a name for it. So in blue, we have the source. In yellow, we have the conductors. And in green, we have the endpoints. So now we can group them as we can give a label for each one of the functions that we are going to talk about. And for example, all the inputs, so for example, a numeric input, a text input, we will call it as a source because it's a source of information. The user will provide something for us. Also for endpoints, we have, for example, plot output or table output. So they are the final result, the thing that we are creating in the server. And in the middle, we have the conductors. So for example, a reactive, which is the most important one. I put these ones down here because they are helpers. They do not really fit in these categories here. But yeah, we will talk about them, and we can pretend that they belong to these groups. Okay. And the shape that we selected here, it's not random, especially if you already used reactlog. If you did, you are familiar with this kind of shape. But also it gives us how do these elements connect to each other. So, for example, source, like a numeric input, can connect with the endpoint. So a numeric input can connect with a chart, for example. Um, Conductors can affect endpoints directly. So a reactive can affect one output in our application. And of course, source, they can affect conductors, and conductors can affect conductors as well. So the shape really gives us the idea on how we can fit one with the other, right? Also, we can create chains. So this chain can be as long as we wish, but it necessarily needs an input and one output. And in the middle, we can add as many conductors as we wish. And of course, the graph can be very complicated because we can have many to many connections. So one input can connect with different conductors, and different conductors can connect with different endpoints. And actually, this kind of approach is how I like to use, it is the way I like to think about applications when I'm developing. So before starting something, I always draw how the graph connects, and then it gives me a better idea on how should I implement the application. And we'll be doing it today as well. And that's all. So we know everything about the reactivity and the components we have. We know the name of the functions, but we have no idea how the functions work. So before moving to the functions, let's see what our client wants, because we need a client to request something for us. And I went through this meeting, and my client just said that she wanted a very, very simple application. And this application will be, okay, we have some inputs, for example, age, weight, gender, activity, which is a sport activity, and the duration of this activity. And we want to return the estimated number of calories that the person burned in this activity. And she said, no worries, we have the formula, I will provide it, you don't need to take care of it. And also, we don't need anything fancy. It can be very simple. We are not interested in the UI, just a plain text is fine. That's what she said. And in fact, she provided me. So this is the way we are going to calculate the calories. Please don't take it too seriously. The numbers, the source of these numbers is just my head, and yeah, it's not true at all. So don't believe on the results of of this calculator, okay? But we can understand how to calculate it. So the calories, the number of calories that you burn, is a result of the division of duration in minutes times the metabolic equivalent. I forgot the T, but this is just a number that gives you a multiplier based on the activity. The age factor, which I will explain in a second, gender factor, the weight in kilograms, times this number, random number, divided by 200. And this MET is depends on the activity you are performing. So if you are playing volleyball, then the number will be 3. If you are running, then this number will be 8, and so on and so forth. For the age, we have some groups. If you have if you have an age between 18 and 30, then this number will be 1. If not, this multiplier will decrease, okay? And the same for the gender factor. So if you are a man, it will be 1.1. If you're a woman, it's 0.9. All right, we have it. And in fact, you don't need to code it because I already did, just to explain you the expression, okay? So everything is independent here. We have a huge multiplication, and that's it. And now we have all the information we need. So we know how the reactivity works. We know the name of some functions. I didn't give you any details, but we'll talk about it. And we have a problem to solve. So what I will try to do is to introduce different things in this example, and then we will be able to use different functions to solve the problems that will come up. So to start, let's talk about the core reactive elements, because Shiny has a lot of reactive elements, but some of them are more important. The most important ones are the ones that the users are going to see. So it's the inputs and the outputs. If you already used Shiny before, you know that we have in the Shiny base several types of input. For example, select input, text input, and so on and so forth. And also different types of outputs, plot output, table output, so on and so forth. And connected with each one of the outputs, we have render functions. So to create a chart, like a plot, you use a plot output together with a render plot. And this is very basic. And to be honest, in the examples we are going to see, we are not focusing the UI. We are focusing in the server side. And the very first function we will talk about is the reactive. And the reactive can be seen as a worker. It will perform a task, so it's very specialized for some task, but it will just perform this task if you request. If you do not call this reactive, it will never execute by itself. So you need to call it and ask, like, please do this task for me. You can use it as many times as you want, and it will change its value. It will be invalidated every time that something that's something that this reactive is dependent on changes. So let's suppose that the reactive depends on the age. If we change the age, reactive is going to change its value. It will be invalidated. So if you are using this reactive in some other part of your code, it will be called and the new value will be computed. So that's what a reactive is doing. And we have its brother, which is the event reactive, which instead of being validated when the dependencies are triggered, it will just be invalidated when a specific element is triggered, the one that we are watching. And it will be more clear when we go to the code. And as I said, you can create a production line, so you can put the reactives in chain. So one reactive depends on the other, and so on and so forth. And you can have a lot of them in sequence. It depends on the how complicated is your example. So it can be seen as a production line. We have the first reactive that's performing a task. It will deliver for the second reactive. The second reactive will transform it and deliver it to the third one, and so on and so forth. So they can be very specialized in some parts of your code. All right, so with the information we have, we can already start our application, and I will be using the graph of it. So the first version is very simple one. We have the inputs, so we have duration, weight, age, gender, and activity. And we need to create this output message as requested by our client. I will be abusing of the notation here, so you can see that there are a lot of things. I will show you during the presentation what each one of those means. But right now, the only thing we are using is the dependence. So the output message depends on duration, weight, age, gender, and activity. And that's what I want to implement. Just create some inputs and the output message. So you can if you have my GitHub already, if you pull the chains, you can run the application by using this code here, and I will show you in my machine also. So please, if the font size is not good, let me know. First of all, let's see how the application looks like. I don't want it attached here. All right. So this is my application. I have the 5 inputs. I have some random numbers here, preset, and we have the result. So if you play tennis for 1 hour and you have 90 kilograms and you are a male with 33 years, that is 33 years old. So this is the amount of calories that is estimated for this activity. So it's very simple as the client requested, nothing fancy, right? But I'm not very interested in how it looks. I want to show you some other things. And let's start with the server. Oh, sorry, the UI first. So in the UI, I have several different inputs. So for duration, for example, I have the okay, I have a request to increase the font size. So 1 second. Let's try 16. And please let me know if it's okay. All right. So for each one of the inputs, I have, for example, a numeric input for the duration. I have some select input for gender and activity, and so on and so forth. Very basic UI. Okay, I will just make one more. Okay, the next one is 18. I hope it's okay now. So as I said, UI, super simple, nothing fancy, okay? The server side, for the first example, is also very simple. We just have a render UI, which you render the message that I'm creating for my user. Most of the examples I will show you, they will be basically the same. So I will focus only on the things that are changing, okay, from one code to another. So if you have my repo there, you can see the example inside of the folder number 01, which is the first example. So what I'm doing here, I'm adding a lot of messages so we can see exactly what's the flow of the application, because I want to see where the application is going and how long is it taking to execute the tasks that I'm requesting. So I will start basically saying like, okay, I started creating the output message, and I will perform like I will just create the message based on the inputs. So I will collect the inputs. I will create the factors. So I will not show you this function, but remember from the presentation, we don't need to pay attention on it, but we have how to create these factors. I already did it, so we don't need to do that. There's a function for it. When you have the factors, we can calculate the amount of calories. We finish because we already created the message. We send a message informing that we finished creating the output and how long did it take. And you display a message for the user. So based on the current setup, you have burned whatever calories. Okay, so super simple. And now let's run it, and well, let's discuss a little bit what's going on here. I want it smaller, like this. So the application itself is not that important, the way it looks, at least. Okay. All right. So I'm running the application, and then we can see the logs here. So I'm creating the output message. I'm creating the age factor. I'm creating the gender factor. I'm creating the MET factor, and I'm calculating how many calories uh, we are burning in this setup. So I'm also like just showing you what are the numbers that we are using and finishing the calculation. You see that it's taking a long time. It shouldn't, but I'm delaying the functions by 1 second just to make it more like painful for us. So in the real case, in the real world, it will the reactives and the functions that we are using, they will take more time than this one. So I'm just delaying it just for fun. Okay, and let's see what happens. So we run the application. We have for the first setup this amount of calories. But well, I'm not 33. I'm 55, for example. So if I change it to 55, we will see that the application is doing everything again. So we did it once at the beginning. It took 4 seconds. And now I change the age, and it's taking again 4 seconds. And as you can see, it's calculating the age factor again, the gender factor, MIT factor, and so on and so forth. And it's completely unnecessary. Why? Because if you have a look at the formula here, they are independent. They do not depend on each other. So if I change the age, it shouldn't, I don't need to recalculate everything here. So I'm basically redoing a work that's not necessary. So we learned how to improve it a bit. So our first example, of course, it was just like super simple, but we can make it a bit more complicated. For example, we can create a reactive which will calculate something that I called adjusted MET. And this adjusted MET will be basically um, this part of the equation here. So I'm dividing now what I'm doing. So first of all, I will calculate what's the result of this calculation here, and later I will multiply everything in the end. So the graph looks more like this now. So duration and weight goes directly to the output message. But now age, gender, and activity are going to a middle process, which will be a reactive. So only when age, gender, and activity change, this adjusted MET will be calculated again. So by now, I will show you this example, but you can maybe tell me in the chat why this approach will be bad also. So, but I will explain this one anyway. All right. So I will open now the second file, which is here, and they are more or less the same. But now I have the adjusted MET, which depends on age, gender, and activity. So every time that I change any of them, we expect this reactive to change, to be triggered, okay? And basically, I'm doing the very same thing I was doing before, calculating the factors and showing the results, okay? So this is the adjusted MET. And in the output message now, I don't need the age, gender, and activity anymore. Everything that I need is inside of this reactive. So now I created a chain, the very same chain as I showed you here. We have the inputs, we have a reactive, and the reactive is connected with the output message, not the very first inputs here. All right, let's see how it goes now. Try something more interesting. All right. So, same thing. first time it's executing. All right. So same thing. First time it is executing, we have it's taking 4 seconds. It's impossible to escape of this fate. So we are taking the age, gender, MET, and making the calculations here. 4 seconds. Now, if I change the duration, for example, remember, duration doesn't have anything to do with age, gender, and activity. And that's what happened. We don't go to age factors anymore. So we are skipping that. So we are avoiding recalculating something that's not necessary, right? However, if we changed age, for example, it will trigger also the gender factor and the MET factor, which again is not necessary because they are independent, as we can see here. So all of the elements here are independent. We created this reactive here just to simplify the logic, but still it's not optimal because they are being dependent on each other here. So this is how it looks right now. And we can do it better. We don't have a limit of reactives to use in Shiny, so we create some specialized reactives, and that's what we do by creating 3 new reactives. So each one of the reactives will be responsible for calculating the factor for each one of the inputs, and then after that, with these reactives, we are calculating the adjusted MET. And why is it better? Because if the gender doesn't change, the gender factor will never change. And then when we are calculating the adjusted MET, it will be instantaneously because the reactive already know the result of it. Nothing changed. So we can just use the number and make the calculation. So let's see how is that in practice also. And then after that, I will stop a bit just to see if there are some questions, but I don't expect because the examples are quite simple, unless you never used Shine before. All right, so let me focus on the difference now. So before we created this one in the previous example, and now I'm creating 3 other reactives, and they are quite simple. So the age factor reactive takes the age and returns the factor for the age. The gender factor does the same, but with the gender, and the activity does the same, but with the activity, right? The rest of the code is the same. I'm just waiting that one to finish. I run it here. As usual, first time we run that, it's taking 4 seconds. Good. And now if I change the duration, for example, it will take just 1 second because duration doesn't have anything to do with the factors that we created. And now we will see also that when we change the age, it just recalculate the age factor and then the final result. So we are not triggering the gender and the activity anymore. So we improved our application a bit, right? But it's still not optimal because, for example, let's see what happens when I change the age here. Age is 34 right now. I will put age 35. The code recalculated, but the number of the calories is the same, 756. If I put 36, it will recalculate and it's the same. And it will be the same always until we get, for example, in 40. Then the number of calories will change. Why is that? because in our calculation here, the age factor just change on intervals. So if you type any age between 18 and 30, it will always be 1. That's the final result for any age in this interval. And if you put this 1 in the calculation, it will not change anything. So that's why it's the result. The final result is the same. So we could improve this code a little bit by, okay, let's check which category the age belongs, and then if it didn't change, we don't need to update our output. So it will improve a little bit the performance here. But before we go there, let's see what we did so far. So very basic functionality so far. What we did was basically to put the reactives in line. So we are trying to understand how the graph works, the dependency between the inputs, and it's always easier when you can draw this and see like simple lines. So you can see the flow coming from the inputs and going to the outputs. If you have something that's very like deep connected and a lot of relationships, it will be very hard for you to understand what's the source of the reactivity in your application. So the very first takeaway from this is try to look at the app flow. If you can draw the flow of your application, it will save you a lot of time. You will understand a lot what's going on in your code, and you'll be able to cut some dependencies that are not really needed. Okay. And it's very important when the application grows, because sometimes you have very, very complicated flows. And if you do not take care properly of it, it will be a Frankenstein very easily. So try to take care of that application flow. Another thing, at least for me, is to create meaningful reactives. We can add whatever we want inside of a reactive. It can be doing a lot of things, but I prefer to create reactives that are performing a very single task. The same way we think about functions. We want functions that are doing a very specific job. For me, I want reactives that are doing a very specific job. And when I have it, it makes it easier for me to understand the application flow. Also, you need to be aware about what's the elements that are triggering your reactives, because every time that you use some input inside of a reactive, your reactive will be reacting to it every time that you change the input. So be aware which inputs are affecting your reactives. Before the client meeting, let me see the chat if there is something. I don't think so. Okay. I always get confused with the word invalidated. Is it the same as triggered? For me, no. Invalidation happens when I know that this reactive depends on something that triggered this reactive. Then I will invalidate the reactive. So I will execute it. That's how I see that. But well, if someone has a different version, please send in the chat. Good. All right. Again, if you have questions, ask in the chat. And as I said, I will be stopping every, 10 minutes to see the questions. And let's go back to our client meeting, which, we delivered. So we had time to deliver what she requested. We know that we can improve that age thing that I told you, but well, we didn't have time, so we presented the result. And luckily she asked us, like, is there something that we can improve in the performance, because there are some users that are frustrated. So yeah, we can go and try to fix that thing with these age intervals. To do so, I will introduce you some other core elements. One of them is the reactive val, which is a holder for a variable. And you can update this value manually. And the difference between the reactive vol and the reactive is that the reactive vol is going to trigger or keep triggering the chain only when its value updates. So if you ever have the number 5 and you do again the process and you update it with number 5 again, it will not trigger anything. But if you change it to 6, then it will keep the reactive chain flow. And we have a family of reactive val, which is called reactive values. And basically, it's a list, it's a set of reactive vals, and then you can store different things. It's not needed to store just numbers or logical values or lists or other things. You can store whatever you want. And now we have another very important function, which is the observe. So I told you that the reactive must be called to be executed. If you create a reactive and you don't use it anywhere, it will never be triggered. It will never be used. The code will never reach that reactive, which is different with the observe. The observe will be always executed. The observe is like a spy. It's spying. It's looking into the inputs or the reactive dependencies that it have, and every time that something changed, it will be executed again. It will be called, and it's used for side effects. For example, you want to update some inputs or you want to update some outputs in the UI. So you can use an observe to do that. And it doesn't return a value, which is different than the reactive, which returns something. And we have its brother, which is the observe event. Like event reactive, it's going to observe just specific elements that you are interested in. So not everything. Okay. All right. So with this, we can think like, all right, we know that the age factor doesn't change between, for example, 18 and 30. So if we change the age from 18 to 30, we don't need to recalculate the age factor because we already did that. So we can think, for example, what if I introduce a new reactive, which basically check which group this age belongs, and then if the group changes, then I keep triggering the rest of the chain. Okay, there are a lot of ways to do that. I'm using the ways just to introduce you the concepts. Okay, but this is one way to think. And you see that we will fail with this one, and that's very interesting, at least for me. So let's see how we can implement that. So basically, we are adding this reactive in the example. Let's stop this one. And let's go to example number 4. So in the example number 4, now I have a new reactive that collects the age range, or this category here. So you change the age, it will catch what's the age and return the age range. So if you have some age between 18 and 30, it will return the very same value. I will ask you now, like, why do you think it will not work? If someone has an idea, and I will keep showing you the rest of the example. So this will return the category. And now I'm saying like, okay, every time that this reactive changes, I want to recalculate the age factor. So again, I'm plugging this in the very same example we have. The rest is completely the same. Nothing changed. So I just added this event reactive and a new reactive that I want to collect the range for the age. So let's see how it goes. All right. As usual, first time we are running it, nothing exciting. It's taking 4 seconds to calculate everything based on the inputs we have. So far so good. Nothing changed. Now what we are thinking is that, um, well, if I change the age from 33 to 34, I don't need to recalculate anything because 33 and 34 are in the same range, because there is a range from 30 to 40 in which the factor is the same. And then I change it and it didn't work. So the idea was very good, but it didn't work. And we can see that when we are computing the age range here, it shows 34 is between 30 and 40. Good. 35 is between 30 and 40. But even though it didn't change, it's recalculating it. Why is it happening? So this is a good moment that we will talk about the difference between the reactive and the reactive vol. So this reactive will be invalidated all the time that the input age changes. So it doesn't matter like if it's 33, 34, 35, every time it's going to get here and the output will be something. But the reactive doesn't know this output. So if it doesn't change, reactive is not aware of that. So that's why it's always going inside of this reactive. This category doesn't change, but it doesn't matter because the reactive changed, because the input age changed. And then we failed, but we have time. The client is not pushing us that much, so we can move a little bit more and think like, okay, I told you that the reactive vol will change, will keep the reactive chain only when its value changed. So we can introduce a reactive vol here. And how I will do that? I will use one observer and one reactive vol. How it works? I have my age. I have something I spy observing the age, and this spy is going to update the age range, which will be a reactive vol, and this reactive vol will keep the chain flowing. Okay, and now you can see that I put some dots in this arrow because this is an indirect dependency, because the observe event inside of it, I will update the reactive value, which is by itself a source of information. So the chain start again, let's say. Actually, the flow just keep going. But this dependency, if you use reactlog, it doesn't exist there. I'm just using that to make it more clear that inside of the observer, we are going to update this reactive val. All right, so let's see how it looks in the code then. Now we go to example number 5. So I'm starting this reactive vol with the value new, and I'm observing every time that the age changes, and I'm doing the following. If the age exists, I'm going to calculate the range, and I'm updating this guy with the new category that we have. Okay, so it starts as new. Every time that the age changes, I'm gonna change the category. And before we were observing directly this are reactive, and now we are observing this reactive vol. Then this thing will only be triggered when this element changes. If it doesn't change, it will never touch this code here. Okay, so that's the biggest change. The rest is the same. And now we can run the application. And the same. First time for second. That's all. But now, if I change the age, it will just compute the category, and it will not do anything because the range didn't change. We can do that for 36, oops, 34, 35, 36, 37, 38. And then when we get in the 40, okay, now it changed. So we can we can change actually the output, because now the number will change. So we are saving some time here, right? And the same will happen if you go from 40 to 50. So we improved our performance here. Okay. Um, well, we could still improve it. So, for example, we know that for gender we have just two possibilities, right? And it's a factor. So we could cache these two values instead of keep recalculating when we change from one to the other. But not let's not talk about it because the client is calling us and we need to show our application to the client. But first, just like some takeaways. So basically, it's very important and interesting to know when to use a reactive and an event reactive. So in this case, the reactive value. So in this case, the reactive value is saving us to recompute things that are completely unnecessary. So sometimes reactives are not the best options, but reactive values instead would work much better. Okay. And here we are with our client. And yeah, the client said like, oh, this is amazing. It's doing the job. We really love it. And we are using it every single day. But when I open the application, there is this default values that they do not really apply to me. And then every single day I need to put like my weight, my age, my gender, the activity. And it actually doesn't change that much. So I don't need to change it every day. Is there a way in which you could like remember what are my settings here? Right. So the application that was not fancy, nothing that had nothing fancy, now will have something fancy, right? So let's try to do what the client wants, and to do so, we will talk about unexpected triggers and how to prevent it to happen. And the very first function we will talk about, and then you see that even though I'm considering this a conductor, it's not really a conductor. So I put some dashes around it because it's a helper. It will help you to control your reactivity in the application. Okay. And the isolate, basically it prevents certain reactive elements to trigger. So let's say you want to know about the age, you want to do something with the age, but you don't want that reactive to trigger only because the age changed. That would be one example. So we will see how to use this with the example we are working. And also we have some options for observe event and event reactive. For example, the option once, ignore null, and ignore init. Once ensures that the expression will be evaluated only once. That's why once. Ignore null, it's logical, so it can be true or false, and it will control when you really want to listen to null elements or not. The default of that is true, so we are ignoring null. So if something is null in your reactive chain, it will not trigger observe event and event reactive. But sometimes it's important to have it and to listen to that because you want to handle the side effect of it. And the same for ignoring it. So it prevents the initial values to trigger something. So you just put all information at the very beginning of the creation of the UI. So you have the age, the weight, and so on and so forth. But for some reason, you want to ignore that. So it could be useful. And then it changed a bit. So now what we have here is a new element that's reading the selection from cookies. The rest of the graph is the same, but now it changes a bit. And how is it working now? Now you can see that this observer here has an arrow back to the inputs we have in the application. And why is that? We start the application, we have the initial values of that. We want to read the information from the cookies. So what were the previous setup for this person, and we want to update these inputs. That's why I put this dependency, that's indirect dependency here. Okay, and it will be the example number 6. So let's see. Oh no, the client called me before starting the implementing that. So the client wants to improve also the message, that's the output of our application. So how can we do that? She just wanted a plain text, but now she also wants to know what are the setup that we have to that we created to use. What's the setup that we use to create the output? Okay, and then it will bring us to the 7th version of it. So let's go back to the 6th one, and which we can run it. And 1 second. Oops, this one. Okay. Let me open this one. Let's open the number 6. Okay, this is the one. Let me check if we have something in the chat. Yeah, we have a lot of things. Slides are beautiful. You should say thank you for our designer, Hubert. Okay, I see that some people, they have some other ideas on how to solve it, which is great. And as I said, the way I'm developing it, it's not the optimal way, let's say, but it's the way I found in order to introduce the concepts that I want. So there are several ways to solve this problem, like really. Probably I wouldn't do the way I'm doing right now. But since I want to introduce all the reactive elements, I'm going this way. So probably you see sometimes like, why are you using this and not using that? But that's the reason. Good. So example number 6. This part of the code is just the same. Nothing changed. But we are adding this part of the graph, which is the part that we are reading selection from cookies. And to do so, I'm observing the inputs that I have, and I will do the process only once. I want to read from the cookies only once. And what I will do is get the cookies, if we have some, and update the widgets. You can see like these functions, I created that because they are not very important for our discussion here. You can investigate how I did that. There is the utils file here, okay? And we are in the example number 6. Good. All right, so let's see how it works as usual. Let me take this one here. Surprisingly, the very first time we run it, it will take 4 seconds. So it's the same as always. Okay, but there is a new message here, like, okay, I'm reading from cookies, which is good because we want to keep the flow. We want to understand the flow of the application, right? So we read from cookies, we compute the age category, and we create the output message. Good. But now let's change. So instead of playing tennis for 1 hour, I'm now playing for 2 hours. So I'm burning more calories. Good. And let's suppose I use that for today and I turn off my application. But then tomorrow I will play tennis and I want to check it again. So I will stop this. And now we will have kind of a problem. Why? So first time I run the application now, it started with the age 33, which is correct. The age factor is calculated correctly, the gender, and so on and so forth. But the first duration that we are using is 60, which is the duration we are using when we create the widget. So it's the very first one. So the application is running with the very first one, and then since it's reading from cookies, it's taking the next the updated element, which is now 2 hours, and doing the process again. But it is not good. We don't want to read. We don't want to update the application twice. It could be very bad. For example, um, let's wait till we change the duration. But let's say that also we changed the age for 50, for example. So now we are saving in the cookies the age and the duration, and next time we run the application, it will be very bad because it will read from cookies. It will run the first setup with the information we created at the very beginning. It will update the age category and also the duration that we put here. So instead of taking 4 seconds as before, it's taking 4 plus 1, so 5 plus 2, 7 seconds. So we are trying to do something good for our client, but actually we are adding a bottleneck in our application. Okay, so this is definitely not good. It's nice that we were able to read from cookies and save information there, good, but well, the functionality is bringing some problems to us for us. All right, yeah, this is the main problem, and then after the break, we will try to solve this problem. And the solution will not be good also, but we will improve it later. So right now, just keep in mind that we are able to read from cookies, so we have the functionality working, but the flow of the application is terrible. We need to change it, okay? So let's have an interval now from 10 minutes. I would say the time, but everyone is in a different time zone, so it will not be helpful. So we'll be back in 10 minutes. Is that all right? So I will turn off my audio and camera, and I will see you in 10 minutes. Bye. All right, I think we are back. I hope you had time to take a coffee and water. Uh, I hope also you are not that tired yet because we have still 50 minutes to go and the examples are getting more interesting now. And I promised you to solve the problems with the cookies that we just introduced, right? But the client is pushing us, so we need to run a little bit. All right, so let's keep going. And as I said, and actually I mentioned that before, but the client wants something else in our application. So she wants to improve the message um, we are displaying as the output. So let's add some more information there, and then the graph starts getting a bit more confused, but we don't have that much time. We need to deliver this task. The clients wants to show it to their users, and to solve the problem we have with the reactivity right now, we will add an action button, and this will be compute metric. So the user will enter the information there, but we will just calculate the metric when the user click on this button. So this is this dependency here. So it's a dependency between the action button and the output message. But also we want to add more information in the message. So to create this message more verbals, we are adding more dependency here, but I'm calling it as isolated dependency. So it's a gray here. Why I'm doing that? Because I don't want the output message to trigger an update every time we change one of the information. Rather, I just want when the action button is clicked. So even though we have a lot of dependency here, uh, the only one that will trigger the output is the action button. So let's see how it works in practice with the example number 7. I need this one. This is the example number 7. And I need also to show you the UI for example number 7. So the UI is very basic. It's the same, all right? But I added this action button at the very end. So that's it. And what we are doing here is we have the cookies as we had before, no problems. However, for the output message, now we have an observe event which only observes the calculate calories here. And every time that the user clicks on this button, it will trigger this observe event and we recreate the message here. Again, there are other ways to do that. This one is just because I want to introduce the isolate for you. And the isolate is here. So every time that I'm using something that depends on the inputs, I'm using this isolate. Why? Because I don't want the message to be updated when the inputs change, but I want to update it only when the action button is clicked. That's what I want. Let's see how it works in practice, and then we will make some tests here. Okay. Sorry. And this is the new message. So for a man or woman, the age goes here, doing some activity for some minutes with this weight. The estimated number of calories is given by the calories expression that we already discussed. So we improve the message a bit. Let's run it. Now you have a button at the very end. You can't see anything because, because we didn't click in the button yet. But what is nice here is that we started. We are reading from cookies. Look, the first time it's running, it's taking the age 33. Remember, it was the one that I started the application. But in the cookies, we changed that. So the age in the cookies is 50. So now everything is being done before we do everything else in the application. Okay. So let's click and calculate and see what happens. Now it will take the correct values from the cookies and it's going to show you a better message here. Okay, so that's something cool. Now also, if you change, for example, the duration back to 60, nothing will happen unless you click and calculate again. So now with this button, you are really controlling the flow. So you just do whatever you want after clicking on the button right here. All right. But let's see a few things here. What happens if I don't use isolate? So here is where I'm collecting the information. So the inputs that I have. And what I will do is I will comment out this part and I will remove the comment from this part, in which I'm not using isolate. Okay. And let's run the application again. All right, at the very beginning, nothing happens. So the same behavior. So we are reading from cookies. The information is up to date here. So far, so good. I will calculate. It will take 4 seconds, as always. And we have the message here. So why did I use this isolate? Because if I don't do that, and if I change the duration here, since I'm not using isolate here, this chunk will trigger again. Because even though the observer is being controlled by the action button, we are creating something that's reactive with this render UI, and inside of it, we are ignoring the we are ignoring the inputs with isolate, but not if we don't use that. So that's the problem. It's gonna trigger as many times as you click in the input, and basically it looks like it's ignoring the action button, but it's actually like I did something wrong in the application. All right. So in this case, the isolate is very important here. Something that's also nice, and I had this problem once, is that, for example, I created this save cookies, and this save cookies function basically is going to save the cookie with a given name, but it's reading from the input. So I'm evaluating this input inside of this function, but it's a function, not a reactive, okay? But if I remove the isolate from this function, what do you think will happen? So I have isolate around everything as before. I showed you it's working. But now there is a function that's evaluating some inputs, and I don't have isolate inside here. What's actually going to happen is that the code will be updated also. So it doesn't matter if it's a function or if it's a reactive. If you are using something that changes, like an input inside of this function, it will also trigger. So you need to take care of how you are creating your functions. Sometimes we want to just simplify the code and then we create a function that use the inputs, and this is okay, no problem. But be aware that if you are doing that and if you are not using isolate, this function will become reactive also. Okay? So that's why we need the isolate around some functions also sometimes. So this is one thing, and when it happened, when it happens, it's very hard to debug what's the problem, because you created a function to simplify the logic and do not look at this, but actually the problem is there. So it's interesting. All right, we solved the problem, but we introduced a new button that the client didn't require. We improved the message, and the flow when we are using the isolate is working quite well. Okay, so this is the current status. So what we learned so far here. We can use once, ignore init, and ignore null to really controls when the reactive event reactives and observe events are going to how they are going to run. So sometimes we want to consider the nulls, for example, and I will show it also later a little bit. You can use isolate to prevent the application to trigger because of one of the inputs. And also we learned that you need to take care with your functions, because if you are using inputs inside of it, maybe your application is going to trigger in place that you are not expecting it to trigger. So be aware of that. And then we presented that to our client, and she said, we are getting there. She really likes this new button, but yeah, she doesn't want it. She wants something that's more reactive, and the experience that we had before was much better. So ideally, we want the calculations to update automatically as the user changes the inputs. So more or less how it was before. But remember, we had a problem, right? So let's talk a little bit about controlling the execution then. So let's prevent the reactive chain to keep going if some criteria are not matched, okay? The first function we will talk about is the rec. So it stops the reactive when some conditions are not met. So basically the codes reach this point, it will gonna check something. If this thing is not true, the reactivity chain will stop right there. Otherwise, it will keep flowing, okay? And another friend that I like is the bounce. And the bounce postpones the execution of a reactive context. So if there's something that's changing too often, sometimes it's nice to wait a small amount of time and wait for the application, to decide what's the final result, or the user to decide, for example, what's the duration. And after that, we keep going with our flow. So basically, it will give a time for our inputs here. Okay. And now the graph is getting more complicated, but don't be scared with that. So this part of the graph is the same. We still have the button here because I still don't know how to remove that. I will show you some other things first. But I will introduce some notes, because what happens if I, for example, remove some of the elements from here and ask the code to calculate. If I do this, I get an error because we are not preventing anything, we are not checking anything in our application, and we are allowing the user to do something like this. So it would be better, since we know how to do that, to inform the user like, okay, you cannot run the application if you don't have a gender selected, right? So what we will do is to create some nodes. So if the input's not selected, or if it's a bad value, we are going to show a node for this input. And to do so, we will have another observer that's going to update these nodes. And this observer depends on our inputs. So we will check the inputs. If the inputs are good, we don't show the nodes. If the inputs are bad, we will show the node, okay? And we have an indirect dependency again, with this observer and the nodes that we have, okay? And also, we will have something new here, which is the thing I called dependency with requirement. So instead of an arrow, it will be a square in the end of this connection. So what's gonna happen is that if this thing doesn't meet some criteria, I'm not going to update the message, okay? And you can see that also I added some requirements all around the application, but I'll show you in the code. this one. Now it's example number 18. Well, sorry, 8. So the nodes. It's a new chunk here. It's an observe event. I'm observing the change in my inputs, and I will show or hide some message. I will show you the message soon. I will show and hide the message if the inputs are good or bad, depending on, uh, on each input. Okay, it's another function. You can see how I do that. And I'm ignoring the first set of elements because I know I'm creating the UI and I know that the first set of inputs are valid. So I don't want to update any nodes in this case because I know that there are no nodes because um, the values that I'm rendering are valid. But after I read from cookies and later on, I want to check it and then update the message. So I'm using this ignore init here. That's one thing. The other thing is the requirements that I'm adding here. So first thing is I can't calculate the calories if I don't have the duration, the weight, and this factor here. So if I don't have it, there is no reason for me to waste time trying to do this because it will be an error. So I'm trying to avoid it, okay? And the very same I can add in other reactives because I don't want to waste time. So if the inputs are not correct, I don't need to wait this 4 seconds to just show an error to the user, right? So that's what I'm doing, and I'm adding this rec all around the application. And as you can see, it doesn't need to be like one for each. You can add, you can separate them by commas and then in this case, you need to check these 3 requirements here. So let's see how it looks like right now. Let me open this a bit. I need this one. All right. So remember, I removed the gender when I was running it for the last time. And now when the code reached this observer that I created and I showed you, it will display this message like, okay, this field cannot be empty. Again, there are packages that can do that. I'm doing it manually just to introduce you some concepts, okay? If you put a valid option, it will update the nodes, and now we don't have this because all the elements are valid, and we can calculate. And that's good. All right. So now we have these nodes, and also we have these requirements. And it means that if I try to run it without the proper values for the elements here, it's going to throw me a message like, okay, we need a set of valid parameters, otherwise we cannot run that. So it's much more informative. If you try to put something that's out of the range, for example, for the age, it's also going to give you a message. So you can control everything, and the application is not going to run unnecessarily. Okay. All right. Okay. So why is it bad? Also, I forgot to mention, but all the ideas that I'm discussing here, I try to write it down. So some of them I'm skipping, so you can try it later and try to understand why is it a problem or why is it improving the application. Okay. And yeah, so the biggest problem here is that the client required no button, and we still have a button, and the button is actually controlling the flow for us. So let's try to remove the button. And that's why it's cool to have this kind of graph, because now it's kind of easy to see how to go from one case to the other. Okay. So just to compare, this is the graph for the version that I just showed you. And this is what I want to do right now. So I'm going from here to here. What's it changing? So I'm removing the button. This is the button. But what was the problem before? I'm starting the application with some inputs. I'm reading from cookies, and sometimes the values there are different. Then I'm updating again the application. But in the meantime, the application was running and showing, displaying the first message, which is not necessary, and then running again with the values stored in the cookies. So basically, what I need to tell to my application is that just run it when the cookies are loaded. So wait a little bit before running, check if the cookies are loaded, and then you can display the message. So what I'm going to do is when we read from the cookies, we will create something like, okay, cookies are ready for you, so you can execute the task. But also, it would be instantaneously, so it would not solve our problem. So what I'm going to do is to add the bounce time. So I will allow the application to update it in the UI, the values in the UI, and then after that, I will update the message. So I'm creating some time, and this time doesn't need to be very huge. It's just like a small amount of time to the application to get ready, and then I will make the computation correctly here. So let's see the penultimate example, which is the number 9. So now I need another auxiliary, which is the cookies are loaded. It starts as false because when we start application, we didn't read anything. As soon as we read from cookies, we will say like, all right, we are good to go. I already read it, okay? Then I will create this other element, which is the bounced version of the cookies are loaded, which will debounce this evaluation here for half a second. So after this element turns into true when we read from cookies, I will wait half a second before do something. And what is this something? This something is to trigger our message. So down here now, I have this requirement. I will just run this piece of code when the cookies are loaded. That's my point here. So the rest of the application is exactly the same, but I'm changing this. Another thing that I would change is that at the very first step, I don't really need to calculate what's the category for age because I already know the default value is 33. So the first category is between 30 and 40. There is nothing I can do about it. So I can save time of this calculation. Actually, this one is super fast, but just to show you the flow, we don't need to calculate it. And when we are observing the input age, I can ignore the first one. So 33 for me is not important because I don't need to update this element here because I know the value of it. So I'm saving the code to go to this chunk at the very beginning of the application. So these are the chains, and as usual, let's run. I need my screen here. Okay, I saved with this 17, it's not a good one. All right, sorry, but okay, it's good that it was 17. Because remember, the first age is 33, and then we change it to 17. So this 17 is stored in the cookies. When I'm reading from cookies, I'm updating nodes. So we have this node. This is not a valid age for us. And we are computing the age category just once, just for 17. Before we were doing that for for 33 and then 17, and now we don't need it. And well, we don't know what to do with 17, right? It's an invalid input, so we just display this message. But let's put 33 now, which is a valid one. All right, so we changed the age, we updated the note, we don't have the red note here. It will compute the category just once and creates the message, which takes 4 seconds. Everything that we created before is still working. Okay, so if you change the age, it will not recalculate anything, so it can see it's 0 seconds because we are in the same group unless we change the group. And then it will take 2 seconds because we need to recalculate the factor. Okay, so what we did here was to improve the application in a way that now we can read from cookies, we can update the first set of inputs based on the cookies. The application is not going to trigger more than once when initializing, and we are avoiding several double triggerings that are not necessary here. Okay. All right. So what should you know based on these examples? So pay attention in which places you are using the reactive elements. So if you have inputs inside of functions, it will be triggering. So be aware of that. For your inputs, try to think about meaningful initial values, or start the inputs inside of your server, for example. Because if you are reading something from the database or from the cookies, maybe you don't need you just need a placeholder for your inputs, and then you can read it inside of your application and already start it with the valid values, for example. What we did here was just a workaround, just to not change the UI that much. Okay. You can use rec to prevent reactivity. So if the reactive is not prepared to work with some nulls or some specific case of based on your inputs, I don't know, I have a reactive that just works for women. So then you put rec gender equals women, for example, and then you would keep the flow just in this case. You can also do that. And also you can use the bounce to wait a little bit, just a small amount of time until the reactive chain settle, and then you continue doing the job that the bounced reactive should do. Okay. And last but not least, we can optimize it very easily. I'll just stop a bit and see if I can grab something from the questions. I will go through the questions later, and I will answer you one by one if someone else already didn't. So just to let you know that you are not going to be without any answers. How is he doing the print logs? I'm using this message. I mean, there are packages also for logs, but I want to make it less complicated as possible, but I'm using just the message. Yeah, and the other ones I will go later in the chat, okay? So for optimizing reactivity, we can think about the bind cache. And why is it interesting for us? Because it can store previously computed results. So when we don't have that many categories for something, let's suppose gender or activity, we have just a few of them, and we are computing the factor, which is based on the gender or activity, we don't need to redo the job every time, since there are just like a small amount of possibilities. We can do it once and catch the result. And it's especially good when the task that you are performing is very time consuming. So you do it only once. Next time you requires it, it's already there automatically. So it's a very good thing. And to use bind cache, it's very cool because it's very easy. So basically, the flow here, the graph here didn't change. What I did was adding the caching after the factors, because this is the task that's taking time, because I put 1 second of delay in each one of that. So every time that we compute the age factor, and we have like 5, 6 categories there, it's going to store the value. And next time that I request that one, it will not trigger again. The same for gender, and the same for the activity that we are performing. Let's see how is that in the code. So this is the very last example. And I will scroll down the last two. So this is the example number 9 that we just discussed. This is the example number 10. So in order to add the caching, it was super easy. I just changed this area of the code. Look, we are just binding cache, and we are saying for which category the result should be stored. So for example, in this case of gender, I want to store different results for different genders. In this case, 2. So this reactive will be evaluated for men, then we will save it in the cache. When we change it to women, it will store that in the cache as well. If we go back to men, we don't need to recalculate because we already know the result. So it will be instantaneously. So we are saving a lot of time here. And the price we are paying is not that much. We are just using like a pipe, bind cache, and saying like what we are, what's the reactive element that's changing for this reactive. So super easy. And let's see how it works in practice. Now our flow is quite good. We read from cookies, we update nodes, then we compute the category for age, and then we create the message, which takes 4 seconds. We are not changing it at all. It's like this since the very beginning. But now if I go from male to female here, it will recalculate the gender factor, which takes 1 second, and we will recalculate the number of calories here. So the total time is 2 seconds. Now, if I go back to men, it takes just 1 second because I already did this calculation before. I don't need to do that again. And of course, if I go to female, instead of 2 seconds, we have 1 second as well. The same for the activities. First time, it will take more time, 2 seconds, for example. I forgot which one was the previous one. Tennis, maybe. And yeah, tennis. Then it takes just 1 second. So very easily we improve the performance of the application. And then sometimes, as I said, when the reactivity that we are, the function that we are using, or the job that we are doing, sometimes it's very time consuming. Maybe just using this bind cache, which is super easy, as I showed you here, will save a lot of time. There are some limits in how much space you can use this, but I think you can change that. I mean, inside of all those functions that I'm showing you, there are a lot of other options. I'm just showing you the basic usage here. Okay. All right. So this was the last function I wanted to show you. And yeah, the takeaway here is that the reactives, they don't remember the previous values on their own. So you need something to keep it. And then the bind cache is the thing that you are looking for. So you can basically cache the results and make the reactives to not be invalidated that often. Then I showed this to my client, and my client said that the app's performing much better than ever, that I did a great job, but the UI is not good at all. And I agree. to be honest. But yeah, this is a story for another workshop then. Now, a summary of the best practice that these are my takeaways, the things that I try to think every day when I'm working with Shiny. So the most important one, like really, is to visualize the flow. I really like drawing it. I don't use the computer, to be honest. I have like paper here and I try to draw it. And very often I see problems in my logic because I have a dependency and it's like, okay, it's not needed. I can remove that, and it solves a lot of problems. And it's very connected with the performance of your application, because if there is something triggering more than once unnecessarily, it means that if you stop triggering twice, you save some time of computation, and then the application will be faster. So yeah, dry the flow, and yeah, you can use the very same shapes as me or whatever you prefer. So be aware that reactive and reactive vol, they have different behaviors. So reactive vol will only trigger something when the value changes, whereas reactive will be triggering every time that something changes inside of it. I always prefer using event reactive and observe event, because then I can control exactly which elements I'm observing. And then, because sometimes using reactive and observe, you forget something that's there inside, it's triggering, and sometimes it's hard to catch it. So I always prefer using the ones that are observing a specific events. There are some options for event reactive and observe event that can be very useful for you, and I try to give at least one example on where to use each in this very example that I showed you. Isolate will prevent you to trigger code when you don't want. So we want to use some of the inputs, but you don't want to trigger the reactive. So you can use isolate. If you use reactive elements inside of functions, be aware that maybe you'll be triggering things that you don't really want. Try to use rec every time that you need to prevent unnecessary reactivity, and the bounce to delay some reactivity. And bind cache will be a friend in case you want to improve the performance of your application. So this is the list of takeaways. Thank you very much. I finished on time. Great. And then audio, if there is something that you got from the audience that I can answer, yeah, I'm here. So thank you very much. All right. So I think in this case, I will go through the questions that are in the chat, and I will answer you individually. Okay. So thank you very much. And yeah, have a nice day. Bye.